Hello, everybody. Thanks for coming. I know you guys had a busy week, and a big party yesterday, so I appreciate you all showing up, and I know this is not taken for granted. So how would you like to be able to use techniques like blue, green, and canary when deploying applications on ECS? How would you like to be able to run spot instances and at the same time have the opportunity to kind of default to on-demand if your spot capacity goes down without having any downtime in availability? So my name is Yaniv. I'm a business development manager for container services at AWS. And I'm going to walk you through a couple of examples of things that you can achieve on the platform and ECS. And then I'm going to hand it over to Mapbox, who's going to talk a little bit about their learning and experiences on the platform. So Amazon ECS is the underlying technology that powers containerized workloads on AWS. It's our native container service. And over the last week, we had several announcements, and we introduced a new technology called Fargate, which allows you to run seamlessly the same containerized workloads, but not having to provision any infrastructure. And we also introduced our support for Kubernetes. But at the same time, over the last year, a lot of the customers that we spoke to have been running ECS at scale and have been using it to gain a lot of those obvious and a bit less obvious benefits when running different types of workloads. And really, when you talk about ECS, this is your underlying orchestration platform, but there's a bigger story here, because as developers, you're looking to get all those benefits that EC2 and all those other services that AWS have at your fingertips, even if you are running containers and not standard EC2s. So things like being able to use secrets management, for example, using parameter store, or being able to attach an IAM role to have access control to other AWS services using a task-level role, or the ability to route traffic seamlessly into your services using ALBs or ELBs or NLBs. And also the ability to have VPC capabilities. So a couple of weeks back, we introduced the capability to attach ENIs, elastic network interfaces, into your running ECS tasks. So now you can have VPC IP addresses that are attached to your ECS task. So ECS task can now get IP addresses and security groups at a task level. And so there are many other capabilities as well. So debugging capabilities, AWS X-Ray, for example, to be able to trace and debug your applications. How would you like to get that capability when your application is running on ECS? So let me just kind of walk you through a couple of very concrete examples of things that you can actually achieve on the platform and when running with ECS. So canary deployments has kind of grown to become a best practice way to migrate your application from version 1 to version 2 in a way that is seamless. So there is no downtime requiring to take your service down, overwrite or replace your files, and then bringing it back up. You just deploy the new version alongside the old one, and then you can gradually start routing real-world customer traffic slowly into your new version. And so you can get that quality assurance of how that new application or how that new version behaves. If you grow confident of the new version quality, you can then route more and more traffic into it gradually until you reach 100%. But at the same time, if something goes wrong, you can definitely roll back the traffic and just hit the blue again with 100%, take the green one or the new one offline, and do some rechecking of your application to make the necessary changes and get it back online. So it's kind of a way to have a seamless way to both get seamless upgrade with rollback capabilities. So there are a lot of ways to implement canary and blue-green deployments on AWS. So I'm going to walk you through one of the reference architectures. This is actually published on GitHub. So if you scan the QR code at the top left part of the screen, you'll be able to hit that page and it actually contains both the diagrams, the explanations, and the code and CloudFormation template that you can just deploy in a click and have it running in your account. So the main idea here is that we're using two different ECS services. One represents our green, which is the new version, and one is the blue, which is our application version already running. So when you want to migrate between those two, you're creating basically a Route 53 record set that points with DNS A records to both the load balancers, the ALBs, that each of them fronts the different service. So one ALB fronts the blue service, and one ALB fronts the green service. And using Route 53 weighted routing policies, you can actually determine how much traffic goes into your blue versus how much traffic goes into your green. So you can use an automated way to kind of have a function that will automatically do that for you. So the way we did it in this architecture is we're using CloudWatch events. CloudWatch events is basically a mechanism in which every time that an ECS task gets run or any other state changes happens, we get an event in the system, and you can put a trigger to run some code as a result of that change. In this case, it would be a Lambda function. So when your new green service ECS task is getting launched and reaches the running state, a Lambda function is getting triggered. We look at the DynamoDB table just to make sure that we don't have the same processing on the same event twice, because it uses an at least once mechanism when throwing out the events to CloudWatch. So assuming that's our first time processing this, we go ahead and execute a step function. Now, what the step function does is it basically takes a first step of routing 10% of traffic to that new service. Then it waits for a few seconds, and then after that, it makes the first verification to see how that green service is running. And it's doing that by using a health check. If everything goes well, and that's kind of the left flow of the chart, it's going on to the next stage of now sending 50% of the traffic to the green. And so 50 will remain running on the blue. Again, some period of time waiting, additional verification, and then taking that final step of 100% to the green and 0 to the blue, in which point you can gracefully take down your blue service and remain with your new application version running. But if something was to go wrong, so the health check for the green service did not go through, that would be the right-hand side of the chart, which you're not seeing because I cut the bottom of the chart. But basically, that step, what it does is it just rolls back those weightings to, again, 100% blue, 0% for the green, and you can take it down for rechecking what went wrong. So I'm going to walk you through a quick demo that will basically do exactly that, and let's see if we can kind of visualize and see how that works in real motion. So I'm going into my console. So this is my AWS console, and the first thing I want to do is I want to look at my ECS console and see what we have there. So we upgraded the UI after launching Fargate this week, so now you get visibility in each of your clusters on what are the EC2 type tasks that are running. Those would be the type that you all know and familiar with. And on the bottom-hand side, you can also see what are the Fargate tasks that are running. Sorry, so these are the two clusters. This is the Fargate portion and the EC2 below. So I'm going into my cluster, which I created for this demo. And currently, the green service does not have, okay. So what I'm going to do is I'm going to take down my task just to kind of it's going again. And I'm going into my green service right now. So my green service, we have obviously two services. The blue does not have, the blue does run the current application. And the green, if you look at the tasks, the green does not have any running task at the moment. So let's go on and update that service manually this time to launch a new task of the new version, and let's see how that triggers the entire workflow that I've just shown you. So I'm going to do an update service, and I'm going to create one task of that new service, keep on all the other configurations for that service as they were. I'm not changing anything in the service definition. And let's do an update service. So now, if I'm going back to my tasks, you should see a new task running pretty soon. It hasn't happened yet. For now, I'm going to show you the Route 53 part. This is actually the record set of my DNS, which is called CON356 demo. And it has two A records, each of them pointing to another ALB. And if you look at the weights, currently 100% of traffic is going to the blue and 0% to the green. I'm going to use a testing application called Flood.io. So Flood.io is an application that allows you to use a grid of servers that can actually load traffic into your application. And so you can test that. So I have a grid of 10 nodes that are currently running, and I'm going to just launch a new test using that grid. So until that starts playing, let's see what happened to my ECS service. So now, as you can see, my ECS service my new ECS task was launched. And so I'm going to go to my step function console. And if I'm going into the state machine which I created, let's see what I can see there. So you can see that already a new state machine has been initiated, and it's currently running. Let's see what it is right now. So currently, this state machine has already taken the first step of changing 10% of traffic to go to that green service, and now it's waiting for 60 seconds. Let's go to the Route 53 and see if that actually has fall through. So yeah, now you can see I have a 90 to 10 ratio. Let's see what I have with that flood service. So currently, as you can see, I have a few requests coming for the green service and few requests coming from the blue. And let's see what happens over time. So in terms of requests per minute, right now I have 47 requests per minute, or 47K requests per minute of the blue, and 41 to the green. So you can see the traffic is definitely starting to shift. Now, take into account that it does take some time for the DNS propagation to take into effect. So if in the Route 53 configuration I change to a 90 and a 10, or a 50 and a 50, that will take a few seconds or 1 minute or so to kind of propagate for you to actually see that in motion. The reason why I'm using this tool and not just a browser is because the browser would just cache whatever DNS response it would get, and so I wouldn't be able to kind of show you that traffic split of that blue and the green service. So if I'm refreshing that and I'm going back to my step function, now let me zoom back out so we can see where we are. So we already took that last piece of 100%, and it kind of finished migrating the full traffic because health checks went fine. So let's see that that actually is the case. Yeah, so you can see that right now 100% of traffic is going to Route 53. And let's refresh our floods. So you can definitely see the weights starting to change. And if I'm going to launch, so that flood is still in progress, but if we give it a few seconds, we will be able to see that the traffic weight's starting to change towards the green from the blue. So let's go into the green just to see what happens. And as you can see, the calls distribution, if you look at the green area, definitely started hitting the green significantly, or almost 100% over the last few seconds. And similarly, if you look at the blue, you will see the same. So this is kind of one example of how you can use canary deployments running with ECS by using the rest of the AWS platform to form that architecture that allows you to have that. Now, that's not the only way to do that. You can use ALBs without Route 53, and you can use target groups in ALBs to get that. So there are a lot of ways. But this is just kind of an example to show you how that can be achieved. How about significant cost savings? Anybody interested? No? So many customers that we have, and Franziska will talk about it in a couple of minutes, have been using Spot significantly to kind of cut down the costs when running especially large scale workloads. But what I'm going to show you now is another reference architecture that it's unique in a way that allows you to have a service that is using Spot as the underlying cluster, but at the same time, it also allows traffic to immediately start routing to an on-demand instance in case, for some reason, we needed that Spot capacity back and the Spot instances were terminated. The basic idea here is pretty simple, and you can look at all the details as well in our GitHub page, and if you scan that QR code again. And it's based on an ability to have two different ECS clusters. One cluster uses Spot fleets as the underlying infrastructure, and the other one is using auto-scaling groups, which use on-demand instances as the underlying infrastructure. Both of these clusters have auto-scaling metrics to be able to spin up and down more instances as the CPU load on the system increases, or drop a few if the load decreases. But the main thing we have here is you will deploy the same ECS service that you have twice, once on that on-demand cluster and the other one on the Spot cluster. So what you will do is you will register those two services into the same target group in your application load balancer, your ALB. And so if you do that, and for example, you have 2 tasks running on the on-demand and 8 tasks that are running on the Spot, then you have 10 tasks that now ALB will seamlessly route your traffic to. Now, if something happens and for some reason you were left without Spot capacity, which is highly unlikely, but just in case, you still have 2 tasks that are running and serving the critical path of your applications as you are recovering your Spot capacity in the background. And one of the reasons, or a few of the reasons why customers use Spot, especially with ECS, is, first of all, ECS is integrated with Spot fleets. So you can actually use a Spot fleet to create your ECS cluster. Not only that, if one of your instances on Spot gets the Spot termination notice, then ECS will take that instance into what we call a draining mode, which means no further containers will get scheduled to run on that instance starting that point, and it will start sending termination signals to the running task, if any, on that node to have them gracefully shut down before those 2-minute interval is finished and the Spot goes down. So it's integrated that way. And also, one of the characteristics of a Spot fleet is being able to diversify. That means that you can use different types of instances, and so give Spot fleet the ability to bid on different types. So if one instance type's price went up, the Spot fleet will be able to bid on another instance type, and so to get you the right capacity back. So the more instances you give it as an option and the more availability zones you give it as a configuration, better chances are it will be able to give you that right capacity at the right price. And as you probably know, ECS clusters are heterogeneous. So you can use any instance types when you're working with ECS for the underlying cluster. So that makes it a really good, suitable workload to use Spot for when running. And when you are running on ECS, often cases, you don't really have to have a specific instance types because you get abstracted by a cluster which actually just wants to have CPU and memory to run your containers on. So whether you're using C4 XLs or M4 XXLs, for ECS, it does not matter that much. What matters is what's your application primitive requesting in terms of capacity. How many CPU cores your application needs, and how much memory your application needs. So for all those reasons, we find that a lot of customers, like Mapbox, have been using Spot to gain those cost benefits. And Mapbox have been using ECS at scale for quite some time now. Last year, They have spoken at reInvent and have kind of elaborated on their batch workloads and how to run them efficiently on ECS using something what they call WatchBot. So this year, they have grown in scale. And it is my pleasure to hand it over to Franziska from Mapbox, who is going to walk you through some of the findings that they have running on our platform in ECS.
So hi everyone, my name is Franziska Schmidt. I'm a platform engineer at Mapbox, and I'm really excited to be here today to sort of continue the Mapbox story from what we talked about last year. So if you ask 10 developers, so Mapbox is a mapping and location platform, and we do beautiful maps. We have a geocoding and search product, and we have a lot of different developer tools that you can use to use maps in your services, such as SDKs for iOS, Android. We even have a Unity SDK that you can use to make games. So what I want to talk about today is the story of our migration to ECS over the last year. And if you ask 10 different developers why they want to migrate to a containerized infrastructure, chances are you get answers something like this. Cost reduction that Yaniv mentioned, faster scaling, and developer productivity. And those are also the reasons why we decided to migrate our infrastructure about a year ago. But now it's a year later, and reflecting on that story, we found a few benefits and advantages and tricks that we didn't anticipate. And I call those the non-obvious benefits. And these are the stories that I want to share with you today. And I hope that you can get some tools to take away in your toolbox at home. Both for how to run things on ECS and how to sort of execute such a large system migration in your organization. So these are the teams and systems that we have at Mapbox. We have teams for directions, geocoding, developer tools, etc. Additionally to that, there's a platform team that I'm part of. And the platform's team mission at Mapbox is to empower the other teams to run their services on AWS successfully, and we empower these teams by also helping them with monitoring and infrastructure setup, cost efficiency, and incident response. And it was the platform's team's job and mission to really spearhead this ECS migration over the last year. And that kind of influenced a lot of the decisions that we made. So I just want you to keep that in mind throughout my talk. So we run kind of two different types of jobs and services at Mapbox. We have processing jobs, and these are kind of batch processing jobs, and API services. An example of processing jobs that we run is we have a data pipeline that gets input data from OpenStreetMap and does some processing on this data and then uses it to run the beautiful vector tiles that we serve. And API services, we have API services for directions, and for example, an API map server that responds with a vector tile when you give it a certain set of coordinates and a style of the map that you want. Let's look at our traffic and scale. So on the processing side, we run up to 70,000 tasks in 1 hour on one cluster. So those could be tasks that are long running for hours or even days, and also short tasks that only run a matter of minutes and seconds. This corresponds to about 200 Amazon EC2 container instances at peak, and our processing clusters are running in 2 different regions in the US. On the API traffic side, the requirements are different, and our clusters look a bit differently. So there we run about 500 to 1,500 containers or tasks at peak, and this corresponds to 40 to 200 EC2s. And our API traffics are API instances are co-located in 7 different AWS regions, which is pretty cool. So we run services in different places in the US, but also in Ireland and in Asia Pacific, like in Singapore. So about a year ago, we decided to migrate our entire backend infrastructure to ECS. And that was quite a big journey and project. We migrated hundreds of different repositories to ECS, and there was a lot of work and documentation going into this. So we migrated for better cost savings. We knew that running on ECS really simply, we'd be able to run multiple tasks on one host, therefore dramatically cutting down the number of EC2 instances we were running, and this assumption turned out to be true. Also, faster and more flexible scaling. So if you're a startup that's sort of responding to live user traffic, it's super important that you can scale up your infrastructure at any given time as quickly as possible. And we know with Docker and containers, we could start up new tasks in a matter of seconds, as opposed to the kind of minute ballpark we're used to with EC2 instances. And finally, increased developer productivity. Since Docker launched, I think in 2013, it's become really obvious to most people that Docker is really a great tool to increase the productivity of your developers by decreasing iteration cycles between going from development environments to production-like and production environments. So these are the obvious benefits. But like I said, I want to focus on, and you've probably heard about the obvious benefits a lot throughout this week. So I want to share some of the non-obvious things that I found. So open source private infrastructure, consistency across the organization, cost monitoring tools that we built, and finally, and most importantly, empowering teams. And I'm going to go into each of these in more detail in a second. So I want you to kind of have some things to take away from today, even if you're just thinking about migrating to ECS, maybe you're in the middle of like transferring your systems, you're already running on ECS successfully, or you're running your systems on Kubernetes or some other containerized infrastructure. All right, let's start out with the first one, open source and private infrastructure. So you imagine you're a platform engineer or SRE or whatever it's called at your organization, and a product developer asks you, how can I run some code on a server? I'm building this new cool feature, and I just want to get it up in the cloud and kind of see what happens. And this is the scenario that we get a lot at Mapbox. So the EC2 story for us looked something like this. The person had to provision an EC2, boot up the EC2, install a bunch of requirements, set up their Node, Python, whatever environment they were running, and then copy the code onto the EC2, probably with some kind of copy or Git script, and then run the application. You probably know what's coming next. For ECS, the story for us, for our product developers, is a lot shorter than this. Basically, all they're doing is a Git push, and then we have a continuous integration system called ECS Conix that builds a Docker image and pushes it into our ECR repository. And then it's pulled onto the EC2, and from there they can run their containers. So you can see here there's kind of a big separation of concerns that the product developers have to think about. It's a much easier focus on just the actual application development code, as opposed to thinking about all the infrastructure craft code. That's kind of our platform engineer's job. So one of the things that we did throughout this migration was to really separate our infrastructure code from the application code. And that was kind of a side effect of the way how we were migrating our services. And this gave us a few benefits. Number one, like I said, our product developers don't need to worry about the infrastructure setup, like booting EC2s or installing things on there. They're just pushing their code to GitHub and then running containers. And the Docker setup is the same as on their local machine. This allowed us to also consolidate our infrastructure script in a better way, which meant it was easier to push out security fixes, etc. And there's another sort of unexpected side effect that we found, which is that we can now open source application code easier. Because we removed all the sort of EC2-related setup, like configuration and key management, et cetera, from the application code, it was much easier to open source the application code. I'm hoping not all of you are thinking this, but maybe some people are wondering, like, why do I care about open sourcing things? So this is Mapbox GL Native. It's one of our most popular open source repositories. And you can see there's a lot of people engaging with it on GitHub. And this is kind of the main reason why you want to open source things. It's a great opportunity to exchange ideas and collaborate with the larger communities and people interested in the domain that you're working in. And this has been super important for us. Also, more eyes on code makes better code. This goes not only for security things, but also for things like documentation. There are lots of people out there who are interested in contributing to open source, but maybe don't know where to start. So documentation is often a great sort of starter fix for people who want to help out in your projects and get involved. And thirdly, developer perks. If you're like me, there are lots of engineers out there who really want to contribute to open source and help give back to the projects they're working on. And if you can make that a part of their job, that's really good for making your developers happy and for your organization. All right, so these are two examples of ECS libraries that we've open sourced. The first one is ECS Conix, and it's our CI tool to build Docker images from GitHub commits and then push them into the Amazon ECR container repository. And the second one is ECS Watchbot, which Yaniv mentioned in his presentation, and it's our library for running processing tasks with the run task API on ECS. So to summarize from this section, migrating to ECS helped us separate our infrastructure code from the core domain code, which brought multiple benefits, such as not having to worry so much about developers being concerned with booting EC2s and touching infrastructure code, but also allowed us to open source more code, which is great for multiple reasons. Okay, so that was number one. Number two was consistency across the organization. So when we started out wanting to do our migration to ECS, of course, we sort of looked at each repository and started the work in parallel. And the first thing that we did, as you do when you want to containerize an app, is write a Docker file. And then once that was done, we were writing some things to make that Docker file actually run on ECS. And very quickly, we noticed that we were writing kind of the same code over and over again. So when that happens, normally what a developer does is to write a shared library that solves this problem and kind of shares that code that you're writing over and over again. So we wrote ECS API, which is a AWS CloudFormation helper library for setting up an ECS-based HTTP stack. Unfortunately, this one is not open sourced yet, but we hope to do so at some point. So setting up this library for sharing the way that we run API services on ECS was super useful for us. It helped us firstly establish conventions and best practices across the way we're using ECS. So whenever your team or organization is switching to a new product or new way to do things, it's really important to establish best practices across your organization to kind of make sure that people are doing it in a similar way and that people have conventions to adhere to. And this is especially important when you're starting out with a new practice, a new product, such as ECS was a year and a half ago, where there just wasn't that many conventions across the industry yet. Of course, with any shared library, it helps reduce copy-paste functionalities, and it's easier to pick up context in unknown projects. So I'm a platform engineer, so I, for example, often respond to incidents about our API services. So having worked with an API map service, for example, it's very easy for me to jump into an API geocoding service, even though I might never have touched this project. But because they're using the same base library, it makes it much easier. And this is, I think, the case for many small organizations where, because people come and go, it might be necessary for an engineer to step into a new project. And when you can save time with context there, it's super helpful. So we use CloudFormation very heavily to achieve consistency across the organization. So CloudFormation is a way to have your configuration changes as code in your repositories. So I think Nora Jones had this quote in her talk 2 days ago where she mentioned config changes might be more dangerous to developers than code changes. And this is really true, I think. So it's super important to have config changes in some kind of version control. And also having version control there allows you to have kind of a space for discussion about any changes and could go back and look at what changes were made. Reproducibility. So of course, if you have a CloudFormation template, it's much easier to go in and copy a stack of configuration as opposed to trying to reproduce a set of clicks that someone made in the UI. We also do standardized usage here. So as you can see on this screenshot, we have a CloudFormation folder in each of our repositories where we save the CloudFormation templates. And so that's just a small thing to do, but it really helps if you're trying to figure out what a stack looks like. Just go to the CloudFormation folder, and you know it's going to be there. And we have this little tool called CloudFriend, It's also up on GitHub, and it makes our CloudFormation templates a bit easier. You know, like working with huge JSON files can be kind of hard sometimes. So there's just some like little helper functions that make our lives easier. Okay, so I mentioned incident response as being an advantage of having consistency across your repositories. And this has been the case for us migrating to ECS too. So we also use CloudFormation to document our alarms. So for example, we have CloudWatch alarms on things like high latency, et cetera. So we can use CloudFormation to see the version control there and have reproducibility of our alarms too. Again, we have standardized usage across repositories, so every repository has an alarms.markdown file where all the alarms are described and documented. And again, like shared libraries help you standardize your use also in incident response situation. So often when you're responding to an incident, it's kind of a stressful situation and you don't want to be looking around for documentation, right? So if you know where to look, that's a really good starting point. And our ECS API library also gives you access to some shared alarm things that you're going to need in each repository anyway, like alarming on error status codes. So you might be thinking, like, yeah, shared libraries are great, but how was that related to your migration to ECS? Well, I think in this case, it was really a factor that migrating to ECS helped us rethink the way we were running our systems and designing our code bases. So I just want to encourage you to, when you're doing a system migration like this, take a pause and rethink about how you design your systems and how you set up your documentation, et cetera. Because I think systems migrations like this provide really great opportunities to do so. All right, cost clarity. So we were running on Spot instances even before migrating to ECS. However, only since running on ECS full time, let's say, we've been able to leverage Spot by default. So by Spot by default, I mean anytime basically a new instance is launched, it's a Spot instance, and we only fall back to on-demand if there's a Spot disruption and we really need more capacity. So how did being on ECS make it easier for us to run on Spot? So on one side, of course, previously with EC2s, we were really reliant on certain instance types. So for example, our API maps service was only running on a specific, let's say, R3 X-large instance type. With ECS, we can abstract this need and only document, let's say, our API maps container needs this much memory and this much CPU. And therefore, on ECS, we're kind of abstracted away from the underlying instance type, which makes it much easier to have a very diverse cluster, which, again, helps you to prevent Spot disruptions. So that part is about preventing Spot disruptions. But when a Spot disruption happens, it's also easier to then mitigate this disruption. Because we have faster task startup on ECS, like I said at the beginning, if there's capacity, starting a new task is a matter of seconds, it's much easier to mitigate losing some capacity because you can just spin up new tasks in a matter of seconds, as opposed to spinning up new EC2s in the 2-minute warning that Spot gives you. It's possible, but it's kind of hard and not necessarily reliable in a production high-scale environment. And we've also done some work to diversify our task placement. So we use task placement strategies on ECS to place our task across different Spot pools and availability zone. So that's the Spot by default part of cost clarity. But actually what I want to talk about is another thing as well. So by cost clarity, I mean insight in cost spending on a per service, per team basis. So what does cost monitoring look like on EC2? It's actually kind of simple. So on EC2, if you want to calculate the total cost of a service, you probably do something like this. You get the total number of EC2s that you're running, you multiply it by the instance type cost, and then you multiply that by the number of hours or duration, total duration that you're running those EC2s. So for example, if I ran 3 API maps EC2s, and they're costing me $16 an hour, and I ran this workload for 10 hours, I'm going to get $480. And this is sort of a simple equation to think through. So this was kind of the point that we were at before migrating to ECS. So when we migrated, of course, we also wanted to keep this kind of level of insight on how much each of our services was costing. But it turned out actually cost monitoring on ECS is a bit more complicated. If you just want to think about what's the cost of my service, well, it's not so easy. Because each instance is running multiple tasks, it's kind of really difficult to know how much a service is costing. Also, because different services use up different levels of memory and CPU, so you can't just divide the total instance cost by the number of tasks you're running, because one task might actually be costing a lot more than the other one. So our cost platform engineers came up with a solution that looks something like this. The first step is to find all the tasks of a service. So whenever we launch a new task, we tag it with team and category attributes. Unfortunately, there's no native task tagging yet, so we use the put attribute functions on the family attribute. So for example, when I launch a new task of a project I'm working on, I'm tagging it with the platform team attribute, because the cost of that task is going to be coming back to my team. And the category is, for example, research and development for staging environments, and COGS, the cost of goods sold, for production environments. We then have some algorithms to calculate the total cost of a task through CPU reservations, memory reservations, and the duration this task is running. So it's really important that you're looking at task reservations as opposed to utilization, because if a task is reserving a certain number of CPU, that's the actual usage that it's blocking from other tasks. So while if you're reserving too much, you're still using up that space on the instance. So we use CPU reservation and memory reservation to calculate how much space you're using on the instance. We then aggregate all this usage data in Amazon Athena, and finally resurface the cost info back to the teams who are spending money through a variety of human-friendly communication tools, like GitHub issues and Slack bots. So my colleague Brandon actually gave a full-length talk on this cost monitoring pipeline we built on Tuesday in the CloudWatch track, Dev 33, if you want to check that out later. So the cost information that's coming up looks something like this in a Slack bot. You get the number of clusters and the dollar cost per team on a service. And it's been a really cool tool to empower teams to know how much their services are spending, rather than having this bottleneck of only the platform team and the finance team knowing about Amazon cost. So to summarize from this section, number one, we save costs because we now run on Spot by default on ECS since our ECS migration. And number two, we gain cost clarity through custom monitoring pipelines we've built. So even though cost monitoring initially turned out harder than we expected on ECS, through this challenge that we hit and through the tools that we built to solve it, we now have much better cost clarity insight running on ECS. All right, this brings me to the last point, empowering teams. So actually, a lot of the things that I talked about today were examples of how the platform team at Mapbox has found it easier to empower our service developer teams through our migration to ECS. So they have better tools to launch code faster now. It's easier for them to get started with a new feature. And also, the cost monitoring tools that we built allowed them to have more ownership over their own costs and spendings. So that's really exciting. It's, for me, like one of the best reasons of having our migration to the containerized infrastructure. So hopefully at this point, you're thinking something like this. I'm sold. Like, how can I introduce a large system shift or migration in my organization? And I have a few tips for you on how we did this over the last year, and maybe that you can apply as well. Number one is make the benefits obvious to all. So it's really important that the kind of benefits that you're seeing are shared to the other teams as well. We did a variety of different communication tools to do this. We did FAQs, we wrote internal blog posts, etc. So whatever works best in your organization is really important. Related to this is be empathetic to other teams' needs and perspectives. So you as a platform engineer might be really excited about the cost savings on AWS that you're anticipating. However, chances are that the product service teams you're talking about are much more interested in launching this feature they've been working on for the last 6 months. So for them, it might be more applicable to lead with the developer productivity benefits that you're seeing. So it's really important, in this case, to think about the audience you're talking to and use that benefit appropriately. Introduce plans timely to get the work on other people's roadmap. So like I said, we started with our ECS migration over a year ago. And at the start of 2017, we wrote this really long, big checklist to get this migration across all the other teams. We had 3 months, 6 months, and 9 months check-in points with each team to see how they were doing with their ECS migration. It's really important to kind of, especially with a project of this scale, have some idea of the roadmap and get this work on other people's roadmaps early. Incorporate fun in migration. So this might vary on sort of the way that your business culture is, but I think it's really important, especially with a huge project like this that can take up to a year, to have some element of fun and motivation. So at Mapbox, we actually ended up printing stickers and posters for our teams that got them really excited about migrating to ECS and joining in. So this worked really well for us. And the last point is offer deliberate time and support. So if your team is set up anything like this, where there's one team sort of spearheading the migration for others, it's really important to think about how you're going to offer support for other teams. So we did a variety of different support areas, let's say. So we decided to offer weekly office hours where other teams could come in and check in with us about how their ECS migration was doing. We also offered what we called a platform pop-ins, which is something like a person that is your personal migration assistant that would review your pull requests and do things like check in with you every once in a while to see if they could help with your ECS migration. We also deliberately thought about what time and support we weren't able to offer. And that's something that's also really important. When thinking about time and support you want to offer, think about things that you can't do. So for example, we were happy to review pull requests, but we just didn't have the time and bandwidth to actually do all the migrations for each repository ourselves. And thinking about these boundaries and how to set them early is also super important. All right, so we talked about a few of the non-obvious benefits that Mapbox found in our migration to ECS over the last year. So let's check in now. We're at the end of 2017. Our service is running on about 95% on ECS, and the remaining 5% are mostly services located in China where ECS was only recently announced. We're also running about 95 to 100% at times of our services on Spot. So we're hoping to continue this journey on Amazon ECS, check out all the new features that were announced this week, and further develop our scale and cost monitoring tools that we built. Yeah, so this is the end of my session. Thank you all so much. It's been really fun. And I'll be around downstairs to answer any questions. Thank you.